going to work on the LeetCode problem 1028, recover a tree from preorder traversal. So the question says we have a DFS preorder traversal on the tree. The root node is given is as root, and this tree is a binary tree. And at each node of this traversal, we output some node value with some dashes, and where dash d and where d is if d is the depth of this node, then the dash will be having d plus 1 dashes. For example, if we see that here, the one has the root node has a 0 depth, so it has 1 here, and before 1 there is a dash is just has 0 length, and on these two nodes, they are the layer with depth 1, so that before these nodes the dash length will be just 1. This is the dash for this node number 2, and for this one with the node value 5, this is its corresponding dash, and so on, right? For example, for this node, its value is 6, so it has the dash length will be 2. It has 2 dashes in front of it. So our goal is to reconstruct this tree. So we need to return the tree's node, tree's root, and with all its left child and right child correctly connected to each other. So if, for example, if we are given this string, our goal is to reconstruct this string and return its root node. So I think it's very natural to use recursion to solve this problem, given the number of nodes are not so large. It's only from 1 to 1000, and the node's value is also reasonable. It can be represented by the integer 32-bit integer. So we can use recursion to solve this problem. So the way we do it is to recursively solve from the beginning to end, and whenever we notice that we record the current current depths we have, and whenever we see that the next step's depths will be larger than the current one, then we know that it should be connected as a child. And if the next number's depth is equal or is less than the current one, and we should return it means that one is not a child of this current node. So let's write the code here. Maybe it'll be more clear after we do the code. First, we will actually loop over this string and get all the value and its corresponding depths. So we use a vector of pair to record this information. So vect I means is a pair with the depth and also with the depth and the node value. Okay. So first we do this. For I equals 0, I less than, we say just make it shorter to save some time. So we say the beginning of the depth is 0, and while I is valid, and also the character at this position is dash, then we do d++ and I++ as well. Okay, then we have the depth for this node. Then we try to extract the value. If I is valid and also this position is not equal to dash, then we know that it is part of the value, so we add it to the value. We remember to increase I after we add it. Okay, then we can push back the depth at this position and also the value. The value just string to integer. Okay, then we actually so for example, if it's for example 1, then for 1 something like this, then we know actually we're at the position of a dash. Okay, it's so i's position is here or here. So after this loop, we will increase I by 1. This will cause some problem. So here we actually need to decrease by 1. Another way to write is just to delete this I++ from this for loop. This way, we can extract all the values of vector. So we will first validate whether we are doing this correctly. Then before we move forward, this way it is a more manageable way to solve this problem, I think. So it's first, then second, we will run to see whether we are doing this correctly. The answer will be wrong, of course, but for now we can see that 1 is 0 and this is 1, and 2 for 3 and 4, and 5 has only 1 dash, 6 and 7 are both 2 dashes. The depths are 2. Okay, it seems correct, so we will continue. Then we just return some DFS function, right? And we will implement this DFS function here. This tree and DFS. The parameter is actually the depth. So suppose we want to know the current index of the vector. So we use k to remember that. And if the current location is outside the scope equal to size, then we know we are finished. Then we can return a null pointer. Otherwise, we will do some work here. We will first extract the value. The value is actually the vector at k and the second, right? Then we will make a node, make a tree node with this value. Okay, then we move k 1 step forward, and if k is valid, means it's less than size, and we need k, the depth at k should be larger than the current depth. Then we first do the left node, because the question said if it has only one child, then the child is guaranteed to be the left. So left equals to DFS and depth plus 1. Okay, then for the other child, it's similar. Child right equals depth plus 1 as well. After that, we just return node. Like we test our result. Okay, it seems correctly, and we will submit. Okay, yeah, then we solve this problem. Thank you very much, and see you next time.